Something extraordinary is happening tomorrow, an event that could change everything we think we know about the most mysterious object currently in our solar system. We don't yet know whether we're looking at a strange, ancient cosmic rock, or the first undeniable evidence of alien technology. And in less than 24 hours, we may finally have our answer. But here's the twist. We won't be able to see any of it happen. Tomorrow, October 29th, 2025, the interstellar object known as Atlas will reach perihelion, its closest point to the Sun. It will pass within 203 million kilometers of our star, roughly 1.4 astronomical units, just inside the orbit of Mars. According to Harvard astrophysicist Avi Loeb, this is what he calls the decisive test of Atlas. It's the moment of truth. This will be the hottest, most intense phase of Atlas's journey through our solar system. At that distance, the object will be bombarded with 770 watts of solar energy per square meter, a level of heating that can trigger dramatic changes. For a natural comet, this energy typically causes sublimation, a process where solid ice turns directly into gas, forming the iconic glowing halo and trailing tail we associate with comets. But Atlas is not acting like a typical comet. If it is truly natural and held together by weak gravitational forces, this intense heating could cause it to fragment, breaking into pieces that vaporize rapidly, generating a spectacular display of dust and gas like cosmic fireworks. However, if Atlas is not natural, if it is in fact technologically manufactured as some of its strange properties suggest, it may behave very differently. It might maneuver, it might release mini-probes, it might emit artificial lights or excess heat, as if powered by some kind of engine. And tragically, we won't be able to see any of it. Our view of perihelion is completely blocked by the glare of the sun. We are, quite literally, on the wrong side of the solar system at the very moment Atlas reveals its secrets. This leads to a deeply unsettling question that Avi Loeb raised in his most recent paper. Was this trajectory fine-tuned by extraterrestrial intelligence? The Trojan horse. Question. Loeb calls this the fundamental question. Is Atlas a Trojan horse? Does it wear the disguise of a natural comet while carrying something much more complex or dangerous inside? He draws a chilling historical comparison. The city of Troy, whose defenders were deceived by a wooden horse, believing it was a gift, when in truth it concealed a deadly threat. What if Atlas is following the same pattern? This isn't just theoretical. Loeb recently co-authored an official government advisory urging policymakers to consider the possibility of a black swan event, a high-impact, low-probability threat caused by an unusually massive object traveling along the ecliptic plane, just like Atlas. And here's a final eerie coincidence. Atlas's perihelion is occurring just 2 days before Halloween. So the question becomes, is Atlas wearing a comet costume, or is it truly a natural icy wanderer from the stars? The revolutionary discovery. We've been tracking Atlas since July 2025, when it was first detected by the Asteroid Terrestrial Impact Last Alert System, ATLAS, a global network of telescopes based in Hawaii, Chile, and South Africa. These observatories scan the night sky for moving objects. On the night of July 1st, they spotted something new, a fast-moving speck. At first, astronomers assumed it was just another asteroid. They tagged it, logged it, and prepared to move on. But then, something caught their attention: its speed. When they measured its motion, the data was shocking. This was the fastest object ever detected in our solar system. For context, Earth travels around the Sun at 30 km/s. Mercury, much closer to the Sun, orbits at about 48 km/s. But this new object? It was moving at 58 km/s, and it was still way out, just inside Jupiter's orbit. At that speed, it was clear. Atlas wasn't part of our solar system. It wasn't orbiting. It was simply passing through, on what scientists call a hyperbolic trajectory, a path that originates in interstellar space, loops around the sun once, and exits forever. The third interstellar visitor. That's when astronomers gave it a name, Atlas. It became the third confirmed interstellar object in history. The first was Oumuamua, detected in 2017. It was also bizarre, but in a completely different way, long, narrow, tumbling erratically, and showing no comet tail despite getting close to the sun. The second was 2I Borisov, discovered in 2019. Unlike Oumuamua, Borisov behaved more like a classic comet, albeit with an interstellar origin. But Atlas is different from both. There are three key differences between Atlas and its interstellar siblings. 1. Size. Oumuamua was up to 400 meters wide. Borisov was roughly 1 kilometer. But Atlas? It could be as wide as 5.6 kilometers, massively larger than either. 2. Speed. Atlas moves nearly twice as fast as Oumuamua or Borisov. It's not just passing through, it's racing through. 3. Direction. Oumuamua came from above the solar system, the northern sky, consistent with the direction the sun is moving through the galaxy. But Atlas? It came in flat, along the ecliptic plane, the same flat orbital path where all planets revolve. And that is incredibly unusual for an interstellar object. It's like a visitor from another star arriving with knowledge of our solar system's geometry. In the vast silence of space, where randomness reigns and probability dictates the paths of celestial wanderers, an anomaly has entered our system, one that defies expectations and challenges the very fabric of natural order. Its name is Atlas, and it might be the most mysterious object humanity has ever observed. The tale of Atlas doesn't begin with a dramatic entry or an explosion of light. It begins subtly, almost humbly, like a whisper from the void. While it was officially discovered on July 1st, 2025, its first recorded detection actually came from the Transiting Exoplanet Survey Satellite, TS, on May 7th. Back then, astronomers predicted that its brightness might increase by a modest factor of 1.5 over the following month. But Atlas refused to follow the rules. Instead of a gentle brightening, it experienced an unexpected 5-fold increase in brightness, shocking astronomers and forcing them to reconsider their early models. It was not just reflecting more sunlight, it was reflecting far more than expected. Something unusual was happening. The disk alignment, a coincidence. Too precise. Most interstellar objects don't play by our solar system's rules. After all, space is three-dimensional, and objects from beyond our star system can approach from any direction in the galactic sphere. They don't orbit in neat, flat lines like the planets do. But Atlas did. It entered our solar system from a path just 3 degrees off the ecliptic plane, that flat disk-like alignment around which all planets orbit the sun. In celestial terms, that is an almost perfect alignment. To understand how rare this is, imagine a frisbee spinning in mid-air with planets aligned along its surface. Now picture a grain of sand from another galaxy flying in from millions of light years away, and somehow sliding perfectly along the edge of that frisbee, rather than hitting it from above or below. That's the level of precision we're witnessing with Atlas. This isn't a head-on collision like other interstellar visitors. It's more like a side impact, and its alignment with the disk of our solar system is statistically astonishing. A coma. Too early and too cold comets develop their glowing coma, a surrounding cloud of gas and dust, when they get close enough to the sun for sublimation to begin. That's when frozen material turns directly into gas due to solar heating, forming the iconic tail. But Atlas began showing a visible coma while it was still beyond Jupiter's orbit, over 5 astronomical units, AU, away from the sun. That's highly unusual. At that distance, space is so cold that most comets remain dormant, showing no visible activity. Yet, Atlas already had a prominent coma. And it wasn't behaving like a snowball. It was acting like a laboratory experiment in motion. The key lay in the gases it was emitting. Astronomers discovered that carbon dioxide, CO2, was the dominant gas in the coma, not water vapor, as is typical with most comets. The ratio of carbon dioxide to water vapor was around 8:1, a dramatic reversal of the usual proportions. This explains why Atlas began melting so early. CO2 ice sublimates at much lower temperatures than water ice, just like dry ice. And in the vacuum of space, dry ice behaves explosively, creating vapor clouds without ever becoming a liquid. That's what Atlas was doing, turning frozen carbon dioxide directly into gas and blowing it into space, long before any water ice began to react. The polarization puzzle. One of the most baffling discoveries involved light polarization. When light reflects off objects in space, it becomes polarized in predictable ways. Most comets, both from our system and from beyond, show positive polarization. Atlas didn't. It displayed negative polarization, and not just slightly. It showed the most extreme negative polarization ever recorded for any known object. This type of optical behavior implies a surface unlike any we've seen. Not dust, not ice, not rock. Something else. The metal mystery. Nickel without iron. During observations in summer 2025, astronomers detected something even stranger. They found nickel atoms in the surrounding gas cloud of Atlas, but no iron. That's unheard of. In nearly all naturally formed objects in our solar system, planets, moons, asteroids, and comets, nickel and iron are always found together. They're forged in the same stellar processes and appear side by side in geological samples. So where was the iron? Some scientists speculated that the violent CO2 outgassing was forceful enough to drag nickel atoms off the surface, perhaps leaving heavier iron atoms behind. Still, it didn't add up. Then, in late September, everything changed. Suddenly, iron began to appear in the coma. The ratio of nickel to iron shifted quickly toward normal levels, as if the object was gradually revealing a hidden layer beneath its surface. Atlas seemed to be becoming more normal over time, but it was getting there in a very strange way. A future timeline of observation. As Atlas continues its path through the solar system, the timeline of key celestial encounters is growing more intriguing. November 3rd, 2025. Atlas will pass within 97 million kilometers of Venus. During the same week, it may be observed by the JUICE mission, which is en route to Jupiter. December 19th, 2025. Just 6 days before Christmas, Atlas will reach its closest point to Earth, around 267 million kilometers away, assuming its path remains purely gravitational. Avi Loeb has joked that if Atlas is truly a machine, perhaps it will send mini probes as Christmas gifts to humanity. But behind the humor lies a serious scientific mission. Loeb's team at the Galileo Project is actively monitoring Earth's atmosphere via 3 observatories, scanning for unusual objects or activity that could indicate advanced technology. March 16th, 2026. Atlas will pass just 54 million kilometers from Jupiter. At this point, NASA's Juno spacecraft may have a chance to observe it closely, potentially using its instruments to photograph the object or scan for radio signals, looking for signs of a technological signature. The decisive test. Perihelion. The defining moment for Atlas came on October 29, 2025, when it reached perihelion, its closest approach to the Sun. This is where the stakes were highest. The Sun's radiation at this point bathed Atlas with 770 watts of energy per square meter. For a natural comet, this level of heat would be enough to rip it apart, especially if held together by fragile gravitational cohesion. It would fragment, producing bright, chaotic clouds of gas and dust. An extraordinary display. But if Atlas is something more, something artificial, it may do the opposite. Instead of disintegrating, it might stabilize, or even maneuver. It might eject miniature probes. We might detect artificial light, excess heat, or even non-random radio emissions. That is why Loeb called this the decisive test. The object's behavior at perihelion could help determine whether we're looking at a comet or a machine. The Trojan horse analogy. Loeb has posed a provocative metaphor. Is Atlas a Trojan horse? He warns that just as the city of Troy fell for a deceptive wooden gift, we too might mistake Atlas for a harmless natural object, when, in reality, it may hide something much more complex within. In a paper co-authored with colleagues, Loeb encourages global policymakers to consider scenarios involving black swan events, rare but transformative incidents, such as the arrival of a technologically advanced interstellar object. And this moment isn't just scientific, it's poetic. Atlas's perihelion occurs just 2 days before Halloween, so the question becomes chillingly relevant. Is Atlas wearing a comet costume? Or is it something far more advanced, something that only now begins to remove its mask? The road ahead. As we move deeper into 2025 and 2026, one thing is certain. The mystery of Atlas is far from over. Each day, we collect more data. Each observation brings new questions. And in the quiet, dark expanses between the stars, something ancient, or possibly intelligent, continues its journey through our solar system. In a blind date of interstellar proportions, Loeb writes, we'd better observe our date partners carefully, rather than rely on the limited imagination of our Hollywood screenwriter colleagues. The universe doesn't owe us clarity, but tomorrow, and in the months ahead, it may offer something even greater, a revelation. The answer to one of humanity's greatest questions may be just around the corner, and if Atlas is more than ice and rock, it might change everything